date is December 16th, 2004, 50th anniversary, Diamond Synthesis. We're here with Jim Cheney of GE.
And I guess one of the things that I'm kind of curious about is what do you want to hear?
Well, I think what I've been thinking, what is it I want to hear? And I kind of want a sense of what it was like to work at GE in the 50s, I think is mostly what I want. Let's start with your background, though. It's kind of...
Okay, well, I came from a small town. When everybody was in town, it was probably about 500 people. And went to a little 4-room, 8th grade school with one teacher per room, so she had two classes. And I must admit that when I went to the big city to high school, it was just almost too much trauma for me because people were changing rooms every damn classroom.
What city
I
was
didn't
that?
like that. I went to Scotia, which was next to Schenectady, so I didn't go to a big city, but I went to a much bigger one than I came from. And then I actually worked for GE for about a year. After I got out of high school, I went back to take a couple of additional courses. I went to a little college called Siena, which is it's a Catholic school in Loudonville. I used to commute. Well, I've never lived on campus. And there I was taking pre-med until I decided that working 3 jobs to be able to pay for that school was going to be more than I could handle by going to med school. So I switched over and got my degree in biology.
Oh, right.
So it's a rather odd degree for high pressure work, but I didn't need one.
At that point, did you have an inkling of what you wanted to do, or?
No, I got married while I was still in school. I know my father was quite worried that I was going to quit school, and I said, no, it just means I'm going to finish, the next 2 years at night. So I did. I worked several jobs and went to school nights, and then I was looking for a better paying job, and I interviewed down at General Electric for an open position of a technician, and was asked to wait a few days, and then was called into the research labs and interviewed with Dr. Strong and was offered a job shortly thereafter.
So you interviewed at the research lab, or is there another headquarters of General?
No, I actually interviewed at the research lab because that's where Strong was. So I wasn't necessarily looking to work at the research lab. I was looking for something to pay the rent and to pay school, and maybe I could stop working at as a janitor and as a waiter and a few other things to pick up money. So it was a very busy and difficult time trying to work sometimes 2, sometimes 3 jobs and go to school. But that was the way it had to be. So that's okay. And that's a nice way to season oneself too. You get used to working.
Yeah.
So that's where my career began with General Electric. Bundy was out of town the day I interviewed, so it was just Strong I interviewed. He said okay, and I came in another week or so later, and this was in, I guess it was August that I interviewed. Came in September and started to work for them.
So Strong was specifically looking for a technician to work specifically for him?
No, for he and Bundy. They were at that time working on a vacuum panel insulation, which was a very, it was a glass wool filled insulation. It was quite a bit better than just a vacuum panel because it had all these radiation barriers in it, so that one of the problems with the vacuum thing is you could lose a lot of heat with the radiation. So they were in the midst of doing a lot of thermal conductivity tests on different metals, and they had 4 or 5 cells set up, and they needed somebody to take that data, do it, and then I did a few jobs for the appliance department, testing out some deep rat fires and things like that. Then I was there less than a month when Dr. Suits came down and said, let's try to come up with an apparatus that we can study high pressure reactions in.
And that was in 1951?
That was in 51. And I think it was September that we started that, late September, so I hadn't been there very long.
Did you find that your scientific background helped you, even though it wasn't in a specific field?
Yes, you learn something about scientific approach. It doesn't matter where you are. And I had physics and chemistry, and just not nearly as much as the rest of those guys had. And working for Bundy was a real pleasure, because the guy is a natural teacher. He could not help but to teach you. I think one of the things I wrote, we had an experiment on trying to get the the magnetic susceptibility of metals versus pressure, and we had to use 1,000 cycle current so we could see when the magnetic susceptibility changed. We had to check the temperature, so we needed DC for thermocouples, and we needed a heating current, which we used at 60 cycle. And Francis, again, not being what I'd call a formula memorizer, would say, well, we have to have a choke on this. And now, what's the formula for that? And he sits and he derives it. And just goes on when he's driven it, he puts in the numbers, and finally says, why don't you go up to the glass shop and electrical shop and see if you can get them to do this and put this together. That's just one example. Every time we worked out an experiment, sit there with a little patter, and you could see how his mind worked and how you approached things. So I learned more from he and Herb Strong in the 5 years I was at the research lab than I did in all the schooling that I took. And so it was, well, it's fun to work for clever and intelligent people.
How long had he been at the lab at that time?
Bundy and Strong, I think, both had about 5 years at the research lab. Their initial work had been interferometer studies of rocket flames on an off-site situation. You don't light off the rockets in the middle of the research lab, which was downtown originally before they moved out to along the Mohawk. So, and I talked about today, it was a very pleasant place to work. And one of the things that we would do is Bundy lived about 1.5 good-sized city blocks from a creek. And he had a canoe, and I would sometimes stop over early in the morning, and we'd grab the canoe and carry it down to the creek, get in the creek, and then paddle it about 2.5 miles up to the research lab, and get out and climb up the hill and go to work. We only did that on days when we were pretty sure we weren't going to have a shower in the afternoon. But what an unusual thing to be able to do.
So you and Bundy were fairly close outside of work in relation?
Well, I didn't see him a lot, but he moved into Outlaws after I had moved out. That's the name of the little town I came from. And so I knew of him. He lived not too far from where my parents lived, so I was able to, when I was in town and saw him, we said hello. This was even before I worked for him. But it's, well, he had a nice big house, and he again, was very active in the community and everything. So.
Did he go right from school to General Electric, or what was Dr. Bundy?
No, Dr. Bundy originally went, I think, to Ohio University, not Ohio State, where he taught for, oh, I don't know, maybe 4 or 5 years. Gosh, he would have been a good teacher.
And what about Strong? What was his background?
Strong worked for, and I can't remember the name of the company, but an outfit up in Toledo, Ohio, I think, after he graduated. Both Bundy and Strong got their PhDs at Ohio State. Strong, I think, went to University of Toledo. Francis went to a small college in Westerville, Ohio. Then I think, I don't think they were taking exactly the same courses and things like that, but I think they did know each other in graduate school, but I think Francis may have gotten out of school before Herb did. And then they both ended up at one time. Well, Francis, after he taught, and the war came along, he got a job at the underwater sound lab at Harvard, and they were working on sonar, things like this. And then after the war, then he got a job at the research lab, and then Herb had, also ended up at a job there, and they met and shared a laboratory down in the main plant before they moved out to the campus, if you will.
Was GE a pretty a kind of a coveted job for physicists, or what was it that drew?
Well, it would be hard to find a better facility to work at, and GE at that time did a lot of basic research. It wasn't all applied research, but a great deal of it was basic. So if you had a good reputation, you could work on darn near anything you want if you could sell it to management. You had to get okay for it. So it was a very nice place to work. And around there, I think, the labs were much better equipped than any of the college labs around there. And also the GE was the 800-pound gorilla in Schenectady. You could work for the American Locomotive Works for a while, but they were not inclined to do research and things like that. And that was the central research lab for the whole of the company, so that there was a very broad family of things, chemistry, and they had a chemistry department, they had a physics department, they had physical chemistry, they had metallurgy. They were, all these things actually were basics for their, a lot of the products that they made. So it was a good place for a scientist to work, and you had to take only a little bit of stuff that you didn't like to get to do what you did like.
So how broad was GE's reach? They weren't just a New York company. Did they extend?
Well, GE, as far as reach, is I believe over 30,000 people in Schenectady alone, and considerably more than that in plants in Louisville and in Florida and the West Coast. All labs were much better equipped than any of the college labs around there. And also the GE was the 800-pound gorilla in Schenectady. You could work for the American Locomotive Works for a while, but they were not inclined to do research and things like that. And that was the central research lab for the whole of the company, so that there was a very broad family of things, chemistry, and they had a chemistry department, they had a physics department, they had physical chemistry, they had metallurgy. They were, all these things actually were basics for their, a lot of the products that they made. So it was a good place for a scientist to work, and you had to take only a little bit of stuff that you didn't like to get to do what you did like.
So how broad was GE's reach? They weren't just a New York company. Did they extend?
Well, GE, as far as reach for products and things like that, it was worldwide. But they had, they employed, I believe, over 30,000 people in Schenectady alone. And considerably more than that in plants in Louisville and in Florida and the West Coast, all over. And you know, from generators and light bulbs to, you know, just all kinds of funny things. Refrigerators, washers. So
in 1951, the Knolls was a pretty new lab. It had been down.
I think in 1948 is when the lab opened.
Okay.
And you could have almost everything you wanted in the laboratory. Every laboratory had, you know, gas to run Bunsen burners and things like that, oxygen, hydrogen, compressed air, and then a number of dummy outlets that you could have any gas you wanted. And there was a little vestibule outside your lab, and they would bring bottled gases in and hook them up there, so that you had everything you wanted on tap. The chemists, I think, were awfully well served by the glass shop. They had some wonderful technicians who could make wonderful things. And there were a lot of very elaborate glass structures almost in some of the rooms. So
was GE pretty free with the resources? Say, I need this. Was there a lot of red tape to go through, or was it?
As any, they had a budget.
Right.
And that's, I'm sure the director of research had a little pile of money over here that he could draw on. But they would, as a business, they, you know, very well managed. They planned the kind of research they were going to do. Probably 6 months or a year ahead of when they got into it. And then they'd look on what kind of a budget do I need, and they'd have to make some trade-offs on what we're going to do and what we're not going to do. But yeah, they were fairly free with the money. One of the problems we had, I think, as the Diamond Project was that they kind of figured they'd spend so much money. We made a little bit of progress, and then there was a big discussion, were we going to go on or weren't we going to go on? And they'd say, well, we'll fund it for another 6 months, but you know, we'll cut down a little bit on the toll. I think that was one of the problems we had towards the end, attempting to get carbide parts, pieces, because they were so much more expensive than steel for some of the pressure vessels. And it's a little, you know, cutting off your nose to save your face, because had we had the carbide parts earlier, I think the problem would have been solved a lot earlier. And we couldn't get carbide parts for every apparatus. We got it for the belt set, and then Herb had the steel tapered cone device, which in steel would not get enough pressure to make diamonds. But when he got it made in carbide, it had enough pressure to make diamonds. Well, you know, decided to put the money into the belt, and you know, that wasn't a bad thing. But as I said, that, you know, be interesting to know what would have happened if Herb Strong had used the carbide, because the way he wrapped his diamond seeds in iron absolutely would have grown diamonds if he had the pressure.
So he just had an iron foil that he wrapped the seed crystals in?
Yeah, the thin iron foil, and you know, it wasn't there'd be a little better than a 1/4 inch square of thin foil, and you'd put this little short seed in there, 1/8 of an inch long, and wrap it up. And yeah, again, when you got done, you were looking to see whether or not the metal melted, If it didn't melt, you looked at it to see whether or not, previous to the run, you were taking a picture of these things, whether or not there had been any dissolution of the diamond or whether anything had grown on it.
Now, his taper device had a bottom.
Yes.
It had a bottom, and how did you run the current through that cell? You just connected a current to the top punch
Okay,
and the bottom die.
it was gasketed, somewhat similarly to the to Tracy's. It is in there, but the gaskets provided insulation between the punch and the die, so you'd run the thing through the punch, through the sample, and then out the bottom of the die.
Right.
So you just made a circuit out of it. It was all the piston and cylinder apparatuses were terrible. By that, I mean that when you jam that stuff in there, as hard as you do, gosh, it's hard to get it out and have any sample left of any shape. Right. You know, we used to have cookie cutters to go in there, and they were awful. And that was a lovely thing about the belt, because, you know, you take it out there, put something on it, go whack, right through.
So your job as a technician was a lot of this hands-on assembly.
Yes, I got more press time, not necessarily my own press time, running experiments for these people. However, you know, Tracy talks about this leaky old water press, and it was a leaky old water press. You had two valves that you had to control pressure. One of them was a pullback ram, and the other was the ram that was coming down and giving the pressure. Well, you would, to know what pressure you had to get the pressure on the pullback ram, the pressure on the main ram, and then you had to have a slide rule and figure out how much the resultant pressure was, because that's what was doing it. And so you're constantly jogging that, and then you're trying to run a variac over here to put power into it, because we had no automatic control. So it could be run, it was best run by two people or one very busy person. And often Wentworth and Hall would run experiments, you know, together, the two of them down there. Occasionally we would pull a guy, one of the machinists, out of the shop to run the press. That reminds me, the press was in what was the Ford shop in the lab. And it was big old iron tables with all these forging devices to hang on to stuff. And we had a excellent, they were all pretty good, an excellent tool maker. And he was helping Francis Bundy run one time. And the tool maker, or the forger, was not very busy at the time. And so he was watching, and he finally got a hand sledgehammer, and he came up to one of these metal tables, and he went go wham. And the tool maker running the thing thought it blew out, but then he said, it isn't quite right. And he jumped right up in the air, both feet off the ground, but didn't let go of the handle. And the run was about over, and he brought it down, and the minute the press opened up, he took off after the forger, chased them all through the shop.
Now, for this Birdsville press, they had to build a special area. Did they use the Ford shop? Where did they?
Yes, they put it into the Ford shop just because there happened to be some room there. And one of the problems, if you will, is that, first of all, the press was designed before we had any idea what kind of equipment we were going to use. When we were thinking that perhaps we'd have to run something like some of Bridgman's successful anvils, which had self-relieving tapers on the ring set, which means you'd assemble the ring set as you were also putting pressure in the bore, and then at the end you would let off on the bore and you would let off on the ring sets, and the ring sets would self-relieve. And because of that, you had very complicated rams, and took in every eventuality of the type of apparatus you could run, except the belt. Because no one had envisioned this free-floating body. Now, we could have done something about that. You know, we could have put a little thing in there. But when the press came in, we had the other press set up so it could run the belt or the other apparatus. And I know Tracy wanted very much to get on the press. I don't blame him. But you know, it was suited very well for a Strong's type apparatus. And, it was you know, fun and an odd sort of thing. But the pressure vessels, it's surprising how soon after we were able to generate the pressure that was needed that the problem was solved. That was the main problem of the whole thing, was getting the pressure. And that's where Tracy you know, felt let down, I think, by the physicists, because the mechanical investigation section was selected because they had people who could design as much as anybody else could high pressure equipment. So.
I was trying to find a picture of the lab so I could see where your lab was on the.
Well, it was on the back side. You can't, in any of the pictures I've seen, you can't see it. Actually, we stood up and we could see out over the hill now.
Okay, so you've got the Mohawk River, and the pictures I've seen, and there's kind of an L-shaped building and a water tower.
Mm-hmm. And we were on the back of the L.
Okay.
And it, you know.
Did it have a bay door that opened to the outside? Or
well, that's where, you know, there's labs and labs, right? This is where the lab where you did the, you know, you had the gases dripped in and things like that. The place near the Ford shop was down on the main floor and off on the, well, our lab was on the north side of the building, and it was on the east side of the building. And it was put there because that's how you could get the trucks in and unload the stuff. You took down part of the walls to get it in there. I was told today that just a few months ago, they needed room there, and they disassembled and removed the press.
Oh, so the press was there right up to a few years ago, or a few months ago?
Yes.
Okay.
Now they still have.
What things did they use that for? Did they still use
yes,
research with it for all of these years?
I don't know. I wasn't there. They did add another press, and I think the water press has been going for some years. They did add another 1,000-ton press, very similar to that's used in the production operations in GE. And this second press was another press, another 1,000-ton press when you couple the rams together. It just was, it had lovely pressure controls. We fixed it up with pretty good power controls. But to load and unload it, you had to lift the floor plates and crawl down inside it because all the operating was down below. We had a big periscope with the telescope that you could watch what's going on down there. But it was, you know, it was a lovely press, and I'm sure it was nowhere near worn out when it had to go. But it was,
typically, did you spend your day in that room with the press, or were the offices separated? What kind of activities?
Well, the office, the office and the light lab, I guess that's the best thing to call it, were together. And, you know, the belts weren't too big. And what we do is we take those upstairs, and we'd load the cells up there, and then put it on our hip and go
they were carbide,
walk down.
So they're pretty heavy. That was
well, the carbide's only about yay big. They weighed, oh, maybe 30 pounds. I don't know. It was, you know, you didn't run up downstairs.
You looked like a pretty stocky fellow in those pictures. They're pretty good shape, and you carry those around.
Well, you had to be.
Yeah, that's all I can do to haul that aluminum model in there.
No, but you know, then you could take this thing, and we had a little rack on the press, and you take and lift it up on the rack, and lift the rack up and push the thing in, and it would go to a stop and wet it down on the bottom punch.
So you typically spent almost all your time with Herb and Francis.
Yes, yes. Occasionally I would help Tracy, you know, if I wasn't busy with something else, help him make a run.
Did Bovenkirk work with Tracy and Wintorf? Was he kind of specifically
No,
assigned to them, or was he?
When Bundy and Strong began working on the high pressure, they were winding up this vacuum insulation job. It wasn't wound up entirely. And what they decided to do was to pull Herb and Francis out of it entirely and let Bovenkirk finish it up.
He was a mechanical engineer.
Yes. And he worked most of his time on that, and then in his spare time he involved himself in the diamond project. And his lab was right next to Bundy and Strong, so that, you know, lunchtimes he'd come in and you know, that there was an awful lot of cross-fertilization going on there, discussion. So he was up to speed all the while.
What was his office like? Tell me about these lunchtime sessions. You had a gray desk, you had cabinets. I mean.
Well, yeah, gray desks. That's right. And there were two windows which looked out into the thing. The lab was probably 20 foot across and maybe 30 foot deep. There was an island down the middle of it, and there were benches along each side. And then Francis had a desk in front of one window, and Herb had a desk in front of the other window, and I had a desk in between.
A single office that you shared with these three.
Yeah, it all open, no partitions in the thing.
Okay.
But the lab was closed off from the other labs. But
So you had an office with windows that looked into the lab, and the three of you shared that one office with the windows.
The windows were looking to the outside.
Okay, so the lab was the office.
The lab was the office, yes.
Okay.
It's just that the center aisle didn't come all the way down to the windows. And all nice new equipment, and it was just pretty nice.
And your group reported to A.L. Marshall, who reported to Guy Suits.
Our group, the mechanical investigation section, was headed up by Tony Nearad, and he worked for Abe Marshall. Okay. And then Abe Marshall reported to Dr. Suits.
And Dr. Suits was over the Knolls.
He was the big kahuna.
Okay, and then General Electric, the corporate General Electric offices were someplace else that Guy Suits.
That's right. They were in New York. And, he was a vice president.
Guy Suits was a vice president.
Vice president and director of research. He reported directly into Cordner.
Okay, Ralph J. Cordner.
Yep.
Oh, okay. How involved was Cordner in this? Was it something he cared about much, or was he pretty separate? He showed up on February 15th, and that's about his.
Yes,
his
that's right. Yes.
And how excited was? I just kind of want to get a feel for the hierarchy. How excited was Guy Suits about it? Did he?
Well, I think it was
the pushing force, and Guy Suits said, "Okay, we'll try it."
Well, Guy Suits had to be very interested in it, because when we ran out of the money they initially budgeted for it, we had to get more, and the only guy who could give us more was Guy Suits.
And he had to go to Cordner, or just
no, he's got this little pile of money over here, okay?
So he decides between the metaphysical group and the
yes,
chemical group and the chemical
exactly.
investigations and mechanical
And
investigations.
the people working on the CVD type is saying, never mind that, give us the money. And so, there was an awful lot of that. And the guy in charge of the metallurgy department where this type of work was going on was Herb Holloman, who was a very aggressive gentleman. He later became science advisor for Jack Kennedy. So Herb, didn't mince words, didn't screw around. He went after what he wanted. Didn't know if it get. Pardon?
This is Herb Holloman?
Yeah.
Okay.
Yeah.
How was Herb? Strong and was he fairly aggressive politicker? Was he
more
of a scientific?
Bob,
he didn't...
he's very much a scientist. And one thing about Herb is when you look at what happened, he spent an awful lot of time attempting to show that first diamond could have been the first diamond. And he was trying to show that he could have gotten pressure because he had an excursion in this and all that. inordinate amount of time, unnecessary, completely unnecessary. But it was important to him, because everybody began to lose faith in the fact that that was a real diamond. And there wasn't a good test at that time to tell the difference between a natural and a man-made diamond. Now later on, actually it was after he retired, Bundy thought, well, you know, we probably ought to look at this. So he went to Herb and said, Herb, because he'd known Herb longer than anybody, he says, you know, Herb, there's a test now where we can tell whether that's a man-made or a natural diamond. And he says, how would you like to get that tested? He says, excellent idea, let's do it.
So Herb was
very free, no hesitation at all. He wanted the truth. And so Herb had a lot of integrity. And when that thing was tested, when it was shown that it was a natural diamond, he had it published in the same journal that the initial announcement was made in. And it cost him an awful lot of
prestige.
Yes, well, it was a terrible personal thing for him, because he had, you know, he's the guy who hung on to this for so long. However, he was that honest and had enough integrity that the important thing was to get the truth out. And personally, it cost him an awful lot.
When Tracy came on board, did he project a sense that he felt like he was an outsider, that he did I'm trying to get a feel for what the dynamics of the personalities were. Was he the farm kid that was trying to prove himself in the big leagues, or was there any were you too busy doing other things? Were the personality issues something in retrospect you look back and at the time?
Well, I think it developed a little bit, and we might have a short discussion off camera. Okay. Tracy, when he came in, coming in as an outsider. But you know, that's fine. Here's a chemist going to help us. That's great. It can't hurt us. And he's the only guy with any high pressure experience. He was doing.
Oh, he did have high pressure experience.
He was trying to improve the solubility of some plastics, because they were very difficult to get out of stuff. And because the solubility is improved by pressure, he did an awful lot of work with capillary tubes, where he put these things in it and then seal them up and then stick them in a sand bath and build up the pressure that way. Oh, they'd hold quite a bit of pressure. Now, that was the only pressure experience we had in the business, and that isn't an awful lot of.
Wasn't that easy to come by in those days anyway?
No.
Percy Bridgman.
And you know, it's amazing that Percy kept going as long as he did. And you talk about a personality. My God, Bridgman was a funny chap.
Now tell me about it, Bridgman. I need to be going pretty soon, but would you have time tomorrow morning to continue?
Yeah, I would. I would. If
8 o'clock, 9 o'clock. What's
8 o'clock? I can make that.
Okay, as I really should be getting going.
Yeah.
Quickly, when it happens to me, I don't realize it till later down the road. This is focused. Okay, that looks good. Well, where we left off yesterday was talking about Percy Bridgman, so I just wanted to pick that up before I forgot. You wanted just a little bit. You said he was an interesting fellow.
Yes, he was. He visited us. We hired him as a consultant afterwards, and he visited us. And here's a guy, excuse me, who's a prize winner, the top of his field. And back in the mid-50s, he was getting all of $700 a day to consult. We thought that was a hell of a fee. But anyway, he came and primarily looked at what we did. Because, you know, his summary afterwards is, you know, You know, you guys know more about this than I do. And it was, I think he was asked because everybody respected him for the work he had done, that his work was the starting point for the work that we did. And in fact, he's one of the reasons why that new press was so complicated, because of he had used self-relieving tapers on some of his piston and cylinder apparatuses. We felt we might have to do that. We didn't know. We'd never run a piston and cylinder at that time. So we designed a press that could assemble that and still have another ram to come down and push this as a piston in the thing. So it was a rather complicated press, and it was considerably higher tonnage than he had been messing around with. And it made it hard because it was difficult to, well, it took a long time to manufacture.
Yeah.
And so it came in awfully late. It was only there a few months before we had discovered how to make diamonds. And it would take a specialized piston and cylinder. It would take a piston and cylinder. It would take a flat, a straight-sided cone device like Herb's. The thing it wouldn't take without some modification was a belt set. It was never designed for a free body type apparatus. So it made sense to leave the belt in the old water press and you know, to install Herb's apparatus. We were kind of down to those two apparatuses that we were using at that time in the other press. And I think he was slighted about that too, that he thought he had the better apparatus, he should have the better press. And it would not have taken a long time to modify things to do that. But in some ways it was harder to use because it was the operating pressure vessel portion of the thing was down underground. And you had to lift off these big heavy plates, climb down, then load the cells and everything into the press, and come back up, put the plate back on, and then start up the press. Now, it ran beautifully after that. You know, you had nice pressure control and no better power control than you had on the others. But it was, you know, it was the right thing to do. It seemed like the right thing to do at the time. But it also looked like a slight, I think. So, and but the fact that Tracy was relegated to this leaky old press, you have to remember that everybody, until a couple of months before, was relegated to that leaky old press because it's the only damn thing we had. And we did all the development of the apparatus on that.
Now this carver press you talk about, it was just a bottle jack, essentially.
That's it. You know, it's a platform, two things with screws on it so you could raise the top and the bottom, a hydraulic jack, and then a platform on top of the jack. And now, the fun part of that, and I don't know, I guess I got into it in the long form of the thing. We didn't even own it. It was in the glass shop. And so we had to, we had to load up, or we had to take our anvils over to the glass shop, put them in the press, and attach our power leads to them and take our little variac with us, and then sit there and put the sample in and pump it up. And we'd then turn up the power.
So it was sophisticated enough to use the variac. Now, variac was a General Electric a tower control.
Well, a variac is a variable transformer,
Yeah.
really is what it is.
Okay.
It's
The General Electric builds in-house, is that right?
no, in fact, I think Varian Electric built the thing.
Oh, okay.
It was an off-the-shelf item.
Okay.
But and that was fine. You know, it helped us. We did some of the flat anvil stuff from Bridgman. We did Francis's little saucer thing in there for a while, and everything was fine until our first blowout, which sent a little shrapnel here, a little shrapnel there. And this is a glass shop. You know, all these guys are working on this big fancy equipment.
In the glass shop. Was it you borrowed it from the glass shop, took it to your lab?
It was in the glass shop, yeah.
Oh, okay.
Yeah. They would let us use it, but they wouldn't let us take it out of there because they used it every once in a while.
Right.
So they were unhappy with that. Don't know why.
You don't want scrap in the glass shop.
So, well, what we did is we had a heavy piece of Lexan bent up so that we could put over the press.
So you did have Lexan at the time.
Yeah, and that was new though. I mean, that was fancy stuff.
But that's a competing lab, isn't it? Isn't it DuPont?
It might have been, yeah. Okay. I don't care who makes them. You got to do the job. And it was, you know, it was, you know, half, 3/4 of an inch thick. And they felt a little less threatened by it, but they sure as hell didn't like it when it went bang anyway, even though nothing flew around, because, you know, they're there trying to put these little things together. So you could almost hear them groan whenever we'd walk in there to do something. So they were semi-tolerant.
Well, now back to Percy Bridgman for just a
Yeah.
minute. There was a pressure. Let's see I'm going to get it wrong, but Tracy says the conductivity, and it may have been tantalum, a certain wire that you used, the conductivity changed.
Manganin.
The manganin wire, the conductivity changed as a function of pressure, and it turned out that was off by about 20%.
Yes, we did a lot of calibration with that, and that's one of the reasons why there was less push for carbide, because with the manganin gauges, you read those things and it says, hey, you've got enough pressure that you should be in the diamond stable region, and we were off. You know,
so when I said that there had been tests run in the diamond stable region, you said reported to have been run. That was part of it.
Yes.
That Bridgman maybe thought he was in that region.
Exactly.
And may not have been.
Mm-hmm.
Okay.
So,
Which essentially, it was essentially an ohm meter, the gauge you were watching then.
pretty much, yes.
You'd run a current through a wire, and then
pick current, and then you.
Okay, because to this day we have trouble telling you exactly what the pressure is inside a cell.
Oh yeah. We switched over to the
guess.
volume transition sort of things, and they were somewhat better, but even those were off. That's the thing that Kennedy came down and jumped all over GE about on their pressure
So
calibration.
did you work with Kennedy at all?
No.
Okay.
And
He
I'm
sounded like an interesting.
Yes, he did. I think the main interactions people had with him were at Gordon conferences, and I never got to go to any of those things. And
you didn't have any compunction about telling.
No, you know, if Kennedy was going to be there, you knew he was going to pounce on somebody. You just hoped it wasn't you. So, but back to Bridgman. Bridgman, you know, little short guy, very, very pleasant and quiet, and he felt that, he felt he didn't have much to contribute there. And they took him down, they let him put together a cell, they let him make diamonds and things like that, and he was pleased to do that because, okay, he could say that he'd finally made diamonds. And they asked him up again for another consulting trip, and he came and was pleasant and talked to everybody, and then when he got time to go, he went to there and he says, you know, don't bother wasting your money on me. He says, I can't contribute anything to this. He says, thanks for asking. But and that was the last we saw. But when Bridgman was first there, the first visit, Langmuir was still at the lab. He'd retired, but he always came in. Irving Langmuir,
Bring me up to speed. The sound, it rings a bell, but I don't recall.
Oh, well, I'm not up on all the things he did, but he had a Nobel Prize too. So we had no Nobel Prize winners sitting there looking at the microscopes and looking at diamonds for this first time. And you know, one of my favorite pictures from the lab is me sitting on one side of the table, Langmuir on the other, and Percy's next to him. And I'm trying to explain to those guys what they're seeing, and they're both paying attention to me. Once in a lifetime happening. And you know, hey, I'm a 25-year-old kid trying to tell those guys what the hell's going on.
So you were 25 at this
time?
Yeah,
I was the kid.
Okay, because I was thinking more early 30s, like. No, so Bundy and Strong, they were early 40s.
45.
Tracy was
35. Wentworth's only 27. Wentworth's only a couple of years older than I am.
You right straight out of college?
Right straight out of college. pockets full of money. He bought a house, and I was looking at houses, and then I asked him, I said, you know, where do you go to get a loan? He says, I don't know. I said, you just bought a house. He said, oh yeah, but I pay cash.
Where did his family get his money?
West Bend Aluminum. And he had fun summers. He used to earn money testing Evinrude outboard motors on the but he, you know, again, of all the people, I think Bob was the most interesting and, you know, wonderful guy.
I wanted to get a sense for just the feel of working at the labs in the 50s. Is it, you know, anything before I was born? Is, you know, I don't know if you guys were wearing the bearskin coats. You know, I just wanted to feel for, you know, the lunchroom, all of that, just the atmosphere. You show up to work, punch your clock. What was just the whole general routine of the day?
I think the only clocks were for the people who were, well, the shop people, things like that, the unionized
Everybody
people.
on that was salary. They didn't come in at 8 punch o'clock or 5 punch o'clock.
But one interesting thing is that they began to photograph all the notebooks, not the ones we were working on, but the old ones. They had rooms full of them because everybody who worked at lab kept a notebook, and that was for patent purposes, among other things, so that you could prove that you did something on a given day. These things were witnessed at least once a week by somebody else. So, and you know, you had to sign every page that you looked at the thing and that you understood what it said. So you could be called as a witness. So the lady from the library came down to me one day and she said, I've got a notebook here by Cheney. She says, do you know who that is? I said, no, I don't. And so she showed it to me. It was my father's notebook. He spent about a year working at the lab on radios. And you know, it's nothing he ever told me. And it was fun to look through the notebook. And,
I'll be darned.
But again, the lab, very pleasant place.
At the time, I'm sorry, you say they photographed, this was a photostat?
No, it's microfilm.
Oh, okay. They would
Okay?
microfilm them.
Yeah, now, any good Mormon knows about microfilm.
Oh, yeah. I don't know when photostats were invented. I would imagine in the 50s somewhere when they, the precursor to the photocopier.
Yeah. So, well, anyway, we come in and, you know, come into the lab, and we knew pretty well what we were going to do that day, and gathered the stuff together we wanted for the experiments we wanted to do, or sometimes meant going to the glass shop where they had all kinds of tubing of iron, nickel, cobalt, all different sizes, and that was so nice to be able to go up later on and put together a cell of different sizes and have everything there. You didn't have to go order it.
Did you typically have a staff meeting in the morning? Or
no. There were people working on the chemistry, and that was primarily Wentworth and Tracy, who had a lab together, and they were both off doing their own thing anyway. A couple of times a week, the glue holding everything together was twofold. One, a couple of times a week, NERAD would get people together kind of very informally. It was never called a meeting, but it was. It was never organized, but just talk about what's going on.
So NERAD was the leader of the group. It wasn't the Strong who ran this team.
NERAD was the leader of the group.
NERAD was the leader. Yep. There was no implication or no feeling that this is the supervisor.
Strong and Bundy did not tell Wentworth and Hall what they ought to do.
That was my question.
Yes.
Where the marching orders came from.
There was nothing across this way. It was all this one guy up here. And even that wasn't down. It was one guy up here talking to you and getting you to decide what it is you ought to be doing. And throw out a challenge once in a while. And, but very, very relaxed, very conducive, I think, to getting you to think about what you're doing and how you're doing it and how you can do it better. Then the other piece of the glue was the lunch hours, which were extremely informal. We were all brown baggers pretty well, and we'd all usually gathered in Bundy's lab because we had more desks in Bundy's lab, because my desk was in there too. But often Tracy would come up, often went to...
Come up, so their office...
They were down the hall about, you know, maybe 75 feet or something, you know, those are 4 or 5 labs down. And so we just sit there and talk about, you know, what we were doing, what we wanted to do, where we were having problems, or the time of day and things like that. Now the other thing that happened in lunch hours, and this is where I think Tracy began to feel left out too, is that we had 2 activities which we often, not often, but we frequently engaged in. One was going up to Hal Bovenkirk's camp about 15 miles away on a lake where he had a speedboat, and we go water skiing lunchtime. It took us, you know, maybe 15, 20 minutes to get there. We, you know, take a swim and go tow around with the boat a while and come back. And we may be half an hour, sometimes an hour late. What you did is we all made up the time that day. We'd each work late. And that wasn't really an option for Tracy, because he had this large family and building a house, and he had so much going on that he really didn't have free time that he could engage in that. But he wasn't left out because he wasn't wanted. It's because he had other commitments. And the other thing that they did, there were 3 people interested in gliders, Bundy, Strong, and Wentworth. Some days we'd drive out to the airport at noontime. We'd meet with another guy from downtown who was in their gliding club who drove the tow plane, and they'd tow up, and one of them would go for a flight.
Just right there in the middle of the day.
Yeah.
Okay.
And if the weather was good and there were a lot of thermals, you know, you'd watch him, and if he takes off, you know he's going to try to, you know he's not going to come back. So you go back to the lab, and you sit there, and maybe 4 o'clock in the afternoon you get a call from the guy in Massachusetts.
Is that right?
Which meant you went to the airport, hooked on the trailer, and drove there and picked him up. And once again, that's an activity which involved a lot of off hours of time, which Tracy didn't have available to him. And I don't know if he was interested in flying anyway. But it ended up that Bundy and Bovenkirk bought a glider together, a very high performance plane. And later on, Wentworth bought one for himself. But the other activity, which there were 2 other activities that were engaged in by the group, by members of the group, not all the group. Strong and his family and Bundy and his family all liked to ski. They also liked to camp. Well, I liked to ski a little bit too, but I had part of the same problem Tracy did. I didn't have enough money that I could go off to these places very often. But every once in a while, I could. So occasionally I'd go off with Strong when he was going up to Lake Placid or something like that. And you know, that was my entertainment for the month. That was. And
were you married at the time?
Yes. Well, I mean, I got married when I was at the lab, but I was, most of the time I was married, yes.
So Strong and Bundy, they had a family?
They had families, and Strong had a couple of kids, a couple of young men, and Bundy had, 2 boys and 2 girls. And
they were older, their family was older?
A little older, yeah, they were. So those were difficult things for Tracy to join in on, but again, not because he wasn't wanted. because he had other commitments, and he was, very true to his religion. Family was first, and he took care of family, and I think that's wonderful. And now these other people were taking care of family too, but they didn't happen to match there. So.
Now, around the rest of the research lab, did they know what you were up to? Was it pretty general knowledge, or was it?
Well, we didn't talk about it, but yeah, after 3 years, they kind of know what you're doing.
Was there any edict that you're not to mention this around?
Well, we were. I don't remember that. I know that I did not discuss freely what I did with anybody who wasn't in close approximation with us. And whether or not I did that because I've been told not to or not, I just don't recall. Now after, again, it was, we've got a 2-month period afterwards where we've got to do all this work. We have to flesh out the information so we can write a patent. We have to get ready for an announcement. And competing here, the management was absolutely adamant about the fact we had to get the patent written before anything was said. They were also quite adamant about the fact we got to say something pretty soon because it's going to leak out and then we won't be able to get anything. So busy time, those 2 months. You had to get pressure, temperature, catalyst. That was hard.
I like your description of February 15th, where the reporters came, they installed the telephones, they had to.
Yeah. Well, that was. I'm surprised. These people wouldn't have done it for anybody but GE.
Yeah.
Well, maybe DuPont or somebody like that. They say, "Hey, we've got an announcement. We think it's an important announcement. We can't say anything about it then, but if you show up here." We'll go to the airport, we'll fly you to where the announcement's going to be. And one guy was, as I recall, was late, missed the plane. And he got the information that was going to be at the research lab. So he got to the meeting late, but he drove from New York up to Schenectady, which is, must have been a 5-hour drive. So he wasn't the first guy on the wire with the story. There were some people who knew what was going on too. There were a couple of people who had a little change, who went down to sit in their stockbroker's office, and they knew about what time the meeting was, and they bought some GE stock just before that. They had a little insider information.
They'd be in jail with it.
Yeah, and these were not. They had nothing to do with management or anything else.
They wouldn't be in jail then.
No, but they were just a couple of guys who, and none of them got rich off the thing, but someone probably made $1,000 or something.
Yeah.
Because right after it was announced and it jumped up, and then it dribbled down. It came back to where it was. It ought to.
De Beers took a little dip.
Yes.
Again.
It's like go ahead.
So, in just society in general, not necessarily the scientific community, was there quite a little bit of buzz about, wow, look what we've done?
Oh yeah, well it's like when Tracy does something in this community, people, Schenectady, the papers. I thought you had a thing in the announcement. I have the Schenectady papers. Which front page news, big headlines across the top.
I've got the headline. I don't know that I have the entire
I've got the whole
newspaper.
article. I've got one which has been photocopied, and then